in this question, use pi equal 22/7. It says the diagram below shows a scale drawing of a running track. It consists of a rectangle and two semicircles with diameters LM and MP, where LM equal to MP, which is equal to 49, LM and NP equal to 98. All right. All right. All right, let's go. So the first question says, show that the total length of the track is 350. So we want to show that the total length is 350. What we want to put together here is to understand that we have the length 98 is 98 here as well. So we only need to find this distance here and double it, which is the same thing as this, and then add everything up to get the perimeter of this track. Basically, I'm going to say that this is two semicircles of the same dimension, so I'm just going to find the circumference of one, right? Circumference can be calculated by using pi times diameter or 2 pi r, but because I have the diameter, I'm going to be using it. So circumference is equal to pi, which is 22/7, times the diameter, which is actually 49. So if we cancel this out, we are ending up with 154 meters. All right, and that 154 meters is a complete circle, which is this distance, right, plus this distance as well. Because they are of the same dimension, I just use the one formula, circle. One complete circumference, and then that's for that. Let's add everything up. We're talking about 154 should be added to 98 plus 98. All right, so 154 plus 98 plus 98, and there it is that I'm getting 350 meters, which is the total distance around this track, right? All right. All right, there we go. The question said Nathan walked at a constant speed of 1.4 meters per second. Calculate the time it takes to do 7 laps around that track. Remember that 1 lap is equal to 350 meters. 7 laps is equal to 350 times 7. And what are we getting there? 2,450 meters. So you're saying that he's going to be running 2,450 meters. And he's running at a speed of 1.4 meters for every second. All right. So the question is calculate the time. Remember the magic triangle. Magic triangle says that distance is equal to speed times time, right? So we can utilize it. So time is equal to distance over speed. So we're talking about the time. This is going to be our distance over the speed. And the distance to be covered is 2450. All right, that's the distance. And the speed at which this person is running is 1.4. Right? So 2,450 divided by 1.4. And then the time is going to be 1,750 seconds to do the 7 laps. All right, B part, Tafari runs 1 lap off the track in 68 seconds. Determine the number of laps Tafari can complete in 1 hour running at the same speed, which is this. First, you want to convert 1 hour to seconds because he's running in seconds. So 1 hour is 60 minutes. It takes 60 minutes to make 1 hour, all right? And then 60 seconds to make 1 minute. 60 times 60, 3,600 seconds. In other words, In 1 hour, you will have 3,600 seconds. So if he's running 1 lap, right, in 68 seconds, I am able to tell the number of laps. So I could simply say the number of laps, right, is going to equal to 3,600 seconds divided by the time he's taken to do 1 of those laps, right? So 3,600 divided by 68, right? And we're getting here 52.9 laps. But remember now, context of the question, determine the number of laps Tafari can complete. That's the word, complete. He's completing 52 laps here because time would have run out before he would have finished 53rd lap. It's very near, but it still he would need more time to do 53. So he had completely done 52 and didn't finish the other part. So that's the response that you want to hand in for that. All right, Nathan completes running 1 lap off the track every 72 seconds. Tafari and Nathan start running at the same time from L on the track. So they're starting at the same place and they're going to be running. Each complete a number of laps on the track. Calculate the least, this is the key word, calculate the least number of laps that each will complete before they are both at point L again. Basically what they're saying is they're going to be starting at the same spot, right? One is running at 68 seconds per lap, another one 72 seconds per lap. So the question is saying that if they're running at their pace, right? And so how long will they take? Basically, how many laps would they have to do to actually pass back that same spot together? The key word was the least number of laps. This tying with what we call LCM, the lowest common multiple. So in other words then, we're going to compare their laps, finding the lowest common multiple of each. Well, the lowest common multiple of 68 and 72, that's what we're working on here. Quickly, we could use prime factorization, right? So if I know the prime factor for 72, I could simply break 72 down into prime numbers. Well, prime factorization. So 2 times 36, then 2 times 18, then 2 times 9, and then 3 times 3 given 9. So what I'm doing is I'm breaking down each number using prime numbers. And at the end of the day, 72 is the same thing as 2 times 2 times 2 times 3 times 3. That is 72, right? So I broke it down using prime numbers, right? So I want to do 68, just the same. 68, I could use 2 with 34, and then I go with 2 with 17. All right. So basically, 68 can be found by multiplying 2 times 2 times 17. Now, what we're going to be doing now is to utilize these numbers. The numbers are 2, 3, 17. Which one of these numbers would have the most of each? And you take that. For example, if you're looking at number 2, I'm seeing 3 2s here compared to just 2. So the 3 will win. So what I'm looking for, that LCM that I'm looking for, would have 2, 2, 2 in it. If I look at number 3 now, there are 2 number 3 here, and there is none in this one. So I have to put those 2 number 3. I look at number 17, there is none here, and there is 1 here. I put it there. If I multiply all of these together, it's going to give me the lowest common multiple of these 2 numbers. Talking about 2 times 2 times 2 times 3 times 3 times 17. And this is telling me that my LCM is 1,224, right? So in other words, this is This is the actual amount of seconds, all right, that both of them will be running, all right, when they will pass each other at L again. How many laps are they doing at this time? Well, we could simply work it out. For Tafari, we need to look at their, what we need to look at now is, one second, my board froze. All right, it's good again. All right, what we need to look at is the speed. So this is, Nathan is running at 72 per second. So we're talking about for Nathan here. I'm going to put Nathan over here. Nathan, 1,224, divide that by 72. I'm getting 17 laps from Nathan. And for Tafari, is running 68 seconds, 68. So we divide this by 68. 1,224 divided by 68. And I'm getting 18 laps. So when Tafari does 18 laps and Nathan does 17, they both will be exactly at L again. So the lowest common multiple was the principle there that they used.